So the purpose of this activity is really to build some fluency when it comes to doing polynomial arithmetic, whether that be addition, subtraction, multiplication, or division. So I want to quickly go through as many of these as I can. Hopefully if you watch in the descriptor in the bottom of the video, you can jump to the problem that you're particularly interested. This might end up being quite long, so just jump to the ones that you really need to look at. Okay, so as I zoom in, I'm going to think about number 1. So this looks to be a multiplication problem, so I'm going to start doing my boxes. If I want my diagonals lined up, I need to add a 0x in there. So I will do a box of 3 by 3. And I've got my x squared plus 0x minus 3, and my x squared 3x negative 1. I've got in my boxes x to the 4th power, 0x to the 3rd power, negative 3x squared. I've got 3x to the 3rd, 0x to the 2nd, and negative 9x, because negative 3 times 3 is negative 9. I've got negative x squared, I've got 0x, and I've got negative 3 times negative 1 is positive 3. And my diagonals end up lining up in this particular problem, so I end up with x to the 4th, 3 plus 0 is 3, so plus 3x to the 3rd, negative x squared minus 3x squared is negative 4x squared, 0 and negative 9, negative 9x, and then plus 3. So for number 1, this would be my answer. This is clearly based on this symbol in between a subtraction problem. So the first thing that I'm going to do is go distribute that negative. So negative times x squared is negative x squared. Negative times 2x is negative 2x. And a double negative makes a positive, so plus 5. And everything else is going to get copied down. And now I just combine like terms. I've got my x squared term, so 5 minus 1 is 4x squared. And then I've got my x, negative 3x and negative 2x. That makes negative 5x. And I've got negative 7 and positive 5. That ends up being negative 2. Okay, moving on to number 3. This is a division problem. I prefer the tabular method, and that's what I'm going to show today. I noticed that I have a couple of things missing in terms of place value. I need an x to the a 0x squared, and I need a 0x in order for this to work. I'm going to use, I know that I have 2 going this way, my x, and then my negative 2. And then I need 3 columns, 3 areas there, so that I can put in my x to the power of 3, my 0x squared, my 0x, and my negative 8. I almost always start in this upper right corner, my x cubed space. So something times x is x cubed. Sorry about that. So I got x to the power of 2. I can fill down x squared times negative 2 is negative 2x squared. In order to get 0, this has got to be a 2x squared, because 2x squared minus 2x squared is 0x squared, which makes this have to be a 2x. Then I get negative 4. Negative 4x. This has got to be a positive 4x because my diagonal has to be 0. Makes this a 4. And here's my checkbox is that negative 8, which is beautiful. So my answer to this problem is x squared plus 2x plus 4. This is a 3-part multiplication, and so it looks like we've got a multiplication problem right here. We've got a multiplication problem right there. I'm going to focus on doing the first two, and then we'll bring down we'll take the answer from the first two, and then we'll multiply it by the last one. So I'm going to do really like 2 multiplication problems in one. X plus 1, x minus 2. I've got x squared, x, negative 2x, and negative 2, so that's x squared minus x minus 2. So if I wanted to rewrite this problem as is, I would rewrite it as x squared minus x minus 2 times x plus 3. And now I have to do, now I just get to do another multiplication problem again. So I'm going to do it in a different color. I've got that x plus 3, I've got my x squared, got my negative x and negative 2, and now I just keep filling in the boxes. So I've got x to the power of 3, I've got negative x squared, negative 2x, I've got 3x squared, got negative 3x, because a negative times a positive is a negative, and then negative 2 times positive 3 is negative 6. Looks like my diagonals line up, so I am lucky, and the answer to this problem, x to the power of 3, 3 minus 1 is 2, so plus 2, because it's a positive 2x squared, and negative 3 minus 2 is negative 5x, and then negative 6. So this is the solution to this problem. So essentially, we're going really fast through these, but hopefully you start to see that they're not as scary as they look, so long as we start to identify what they are. Again, I've got 2 subtraction problems, so this negative gets dedicated to those 2, and this negative gets dedicated to those 2 factors. I'm going to just rewrite everything because I like to rewrite it after I do a distribution. So negative times x ends up being negative x. Negative times negative 2. Double negative makes a positive, so that's going to be a positive 2. Negative times x is negative x. And a negative times positive 3 is negative 3. Now all I got to do is combine like terms. I've got my x terms right here, so x minus x minus x, so that ends up being just these 2 cancel out, and we're left with a negative x, and then I've got my plus 1 plus 2, so that's 3 minus 3 is 0, so plus 0, or we can just say my answer is negative x. I'd rather deal with a negative x than all of that stuff up top. Okay. When we look at this, it's clearly a multiplication problem. There's no sign in between these polynomials other than they're just parentheses next to each other. So I'm going to start making my boxes. X plus 2. Got 2x squared, negative 5x, and 7. So 2x squared times x is 2x to the third. Negative 5x times x, negative 5x squared. 7 times x, 7x. 2x squared times 2, 4x squared. Negative 5x times 2, negative 10x. And 7 times 2, 14. It looks like my diagonals are like terms, so I'm going to pull those out. Get 2x to the third power, 4 minus 5, negative x squared. Negative 10 plus 7, negative 3x, and plus 14. Ooh, a division problem, our first division problem. First thing I look for is missing place values. It doesn't look like I have any. We got x to the third, x squared, x, and then no x's, and then same thing with the denominator. I've got to build my boxes, and when I start building my boxes, I think I think I need a side of 2 at least for that denominator to go. I need that x, and then the negative 9, the x minus 9, and then I think about the powers up here. X to the power of 3 minus 1 plus 1 is 3, so I need 3 vertical boxes, as well. So I got a 2 by 3. And then my numerator up here, the stuff on top, goes around the outside along the diagonals. And I really like to have those arrows in there. It just really helps me know where things go. So it's a negative 2x squared. Make sure that we get that negative in there, 65x. And then 18. I almost always start with this upper right-hand corner, x to the power of 3 up there. So something times x gives me x to the power of 3. That's got to be an x squared. And then I can fill down x squared times negative 9 is negative 9x squared. I think something times negative 9 is negative 2, 7, I think? Yeah, 7. So 7 sounds good. 7x squared, because 7x squared minus 9x squared is negative 2x squared. That puts me on top with a 7, because 7 times, 7x, because 7x times x is x squared. Then I fill down the bottom. 7 times negative 9 is negative 63, and then x. And so we have to think something minus 63 is negative 65. I think that's a 2. Negative 2. Negative 2x. It's got to go there. And hope negative 2x minus 63x is negative 65. Okay, so that works. Up top, something times x gives me negative 2x, so that's got to be a negative 2. And here's my checkbox. Negative 2 times negative 9. Double negatives make a positive. Positive 18. There's my check. Here's my answer. So the answer to this division problem is x squared plus 7x minus 2. Moving right along. Another subtraction problem. I got to distribute that negative sign, so got negative 2. Got a double negative, so that becomes positive x. I'm changing colors on us here. Negative times positive is negative 2x squared, and then everything else is going to get copied down. Okay, and all it is a combined like terms thing at this point. So I've got my x squares, so those end up giving me a negative x squared. I've got my x's negative 3 and positive 1, so negative 2x. And then it looks like these two guys, positive 2 minus 2, those just cancel out, so my final answer is just that. Okay, I hope that this instructional video was helpful. There's a lot here. There's a lot of really just good practicing of fluency. If you need some additional help, feel free to email me or check out the website and see if you can find some other videos. But we've got a lot of good practice here, just really making us notice what's going on and then kind of just executing what we need to do. So I hope this video is helpful and just getting lots of just little practice. All right, continuing, if we're going really fast, I want to make sure that I get you everything you need. If I've got a 3 by 3, I've got 3 place values, x squared minus 3x plus 2, and 2 minus x plus 2x squared. Notice that they're not in, all of our parts are there, but they're not in order. And that just is going to play something kind of interesting when it comes time to looking at our diagonals. 2 negative x, and then 2x squared. So we've got 2x squared. We've got negative 6x. We've got 4. We've got negative x to the third. And positive 3x squared, because a negative times a negative is a positive. And negative 2x, and then we've got 2x to the fourth, and negative 6x to the third, and 4x squared. And so notice that this time our diagonals happen to be anti-diagonals, if you will, where they just go the other way. And so if I'm combining like terms, I've got 2x to the fourth, negative x cubed, and negative 6x ends up being negative 7. Negative 7x to the third. The big diagonal, 2x squared plus 3x squared plus 4x squared. 2 plus 3 is 5. 5 plus 4 is 9. So 9x squared. Negative 6x minus 2x, negative 8x, and 4. Moving on, this is a division problem. I've got all my place values. I know that one side has to be at least 2 sides because I've got to put that x and then that negative 3 out there, and then top minus bottom plus 1 ends up being 3. So I need 3 placeholders. I've got my x cubed, my negative x squared, negative 5x, negative 3, and x, I said that I do these in different colors. X to the power of 3 makes this x squared, negative 3x, which makes this x squared, which makes this 2x squared to get us negative x. 2x makes this negative 6x. To make negative 5, I need to have a positive x, which makes this top part 1, and my check negative 3. So the answer to this, x squared plus 2x plus 1. Moving on to number 11. X squared plus 7x minus 12 times x squared minus 9x plus 1. The multiplication problem, 3 terms each. They're both trinomials because there are 3 terms each. So I need a box where I can have 3 rows and 3 columns. X squared, 7x, negative 12, x squared, negative 9x, and 1. X to the fourth, 7x cubed, negative 2x squared, negative 9x to the third. We've got 7 times 9, 63, x squared. So negative 2 times negative 9, positive 18. Positive 18 x, x squared, 7x, and negative 2. My diagonals all line up, so I've got x to the fourth in that diagonal. I've got negative 9 and positive 7, so negative 2x to the third. 2 plus 63 minus 2. So that 64 minus 2 is 62, so plus 62 x squared. 18 plus 7, 25x, so plus 25x, and negative 2. So this would be our answer to that multiplication problem. We've got an addition problem here. Notice that the main thing, and that might be a little bit surprising because we've been doing a whole bunch of multiplication and division, but this addition sign, all it means is that everything stays the same and all I'm doing is combining like terms. So I'm going to collect the x to the power of 3 terms. So I've got 2x to the third and x to the third, so that's a total of 3x to the third. I've got negative 6x squared and x squared, so that makes it negative 5x squared. I've got negative 7x and positive 6x, and when negative 7 plus 6 is negative 1x, or just negative x. And then last but not least, maybe we can see it in yellow. I'll do it in black because it's easier to see. Negative 2 and negative 12, so negative 14. This is just a combining like terms problem, number 12. We've got a multiplication problem, but notice that we've got missing terms in here. We can choose to add those, or we can, when we're combining, noticing that the diagonals don't add up. So I am going to probably do the second option, where I just have the 2. Ooh, that is probably not the best line I could have drawn. and by 3, so I've got x cubed and negative 8, x squared, negative 4x, and 4, x to the power of 5, negative 4x to the power of 4, 4x to the power of 3, negative 8x squared, negative 8 times negative 4 is going to be a positive 32x, and 4 times 8 is 4 times negative 8 is negative 32. So I notice that I have no like terms in here, so my answer is just this stuff inside the box rewritten, stuff inside the table rewritten. So x to the 5th minus 4x to the 4th plus 4x to the 3rd minus 8x squared plus 32x minus 32. Continuing division problem again. I'm going to make my boxes. I've got x and 2, and then I need 3 spaces using my formula that I know. If you don't know the formula, that's okay. It's a good guess and check. So x to the 3rd, negative 2x squared, negative 5x, and 6. Got x to the power of 3, makes that x squared, makes that 2x. Diagonally, 2x plus something is negative 2x squared, excuse me. And so I've got to have negative 4 to make that a negative 2x squared, which makes this a negative 4x. Pulling down, negative 4x times 2 is negative 8x. To get 5, I need to add 3 x's. Makes this 3. 3 times 2 is 6. I've got to check my answer to this division problem is x squared minus 4x plus 3. Another addition problem. It's really easy to get caught off guard with these, but it's just combining like terms. So I'm going to combine the x cubes. So x cubed minus x cubed, that's 0x cubed. And I could even just ignore writing it. I've got 2x squared and no x squared, so we have 2x squared. There's no x squared term in the second part. I've got my negative x and my negative x. That makes negative 4x. And I've got my ones place, which is negative 1 and 4, and that makes positive 3, so plus 3. So my answer would just be that. So it looks like this concludes this practice activity. I hope that this was valuable. I know that's a lot of problems. I know this video is very long, but if you were successful in this and you can follow along with me, hopefully that means that you are ready to take the unit test.